All right, time for our fourth and last video. We're still in 4.2. We're still dealing with logarithms. All right, but this time we're gonna deal with some property of logarithms. The thing I like about this is actually pretty straightforward. It corresponds a lot to our exponent rules. All right, and what this is gonna say is if we are adding two logarithms, so when you add two logarithms, like we're doing here, what we can do is multiply the numbers inside of them. All right, so log base b of a plus log base b of c becomes log base b of a times c. All right, and this corresponds, because these are inverses to exponentials, this corresponds to the same idea, whereas if I was multiplying b to the a times b to the c, that would become b to the a plus c. All right, so it's kind of doing the inverse there of what exponents do. All right, so let me just make that a little bit neater. Okay, in a similar fashion, if we subtract two logarithms or three logarithms or however many we want, we will divide the numbers inside, right? So this will become log base b of a divided by c. And then this third one, well, I guess sorry for the second one, this does correlate to the, if I have b to the a divided by b to the c, that becomes b to the a minus c, right? So it's kind of the inverse of that situation as well. This last one really doesn't have a huge correlation to exponent rules, but it is this third rule repeated over and over again. It's one of our most important ones. This is one where I can say this power n, I can actually bring it out in front. I can split up, this is actually multiplying by n times, so I can split it up with addition n times, and this becomes n times log base b of a. And again, this is probably what I would consider the most important one we're going to use when we start solving. And up here, all these ones that we're doing up here, we're actually going to be using kind of in reverse of what they've been doing. Sorry about that. All right, so let's just do this first example here. This natural log, it has kind of everything in together, and this is what I meant by in reverse. We're actually taking one that's already condensed and breaking it up more. All right, so what we can do first is, I don't like this this square root, so I'm going to write it as a 1/2 power. All right, once I write it as a 1/2 power, I can bring that 1/2 out in front with this third rule. So I get 1/2 natural log of x times y. All right, and then I can finish this problem off by splitting this up. This becomes 1/2. This actually gets multiplied by two things now. Natural log of x plus natural log of y, which, just to make this a little bit more, expanded, I get 1/2 natural log of x plus 1/2 natural log of y. We will work in both directions, right? We will go from a condensed one like this to the expanded one, but we'll also work kind of like this one, where we go from an expanded one down to a condensed one. Both places are useful, both are things we're going to be doing, but I will say the condensing, so this second problem, is going to be what we're going to be using most often when we're solving. All right, the last one, this is kind of like when we had that log base 3 of 27, and we knew that answer because I know that 3 to the third equals 27. All right, but I don't know what 17 to what power equals 139. All right, so what we can do is use this. It's called the change of base formula. I'm actually going to see if I can move. Nope. I'm going to erase this bit here because I need to write there. All right, and the change of base formula, it's really not that bad. What it changes, we can change the base to anything we want. Traditionally, we're going to change to either base e or base 10 because, again, calculators. And what we can do is, if I want to say, let's just do base 10, so I want to do the common log of b. All right, I'm just completely changing. I'm getting rid of the base a. I want to change it to base 10. All right, I can do that as long as I counteract that by dividing by the log base 10 of that original base. Right? Like I said, we can do this with base e if we wanted as well. This could have been the natural log of b divided by the natural log of a. I traditionally will do the second one just because natural log is less writing. Right? Again, I'm kind of a lazy person. I write as little as possible. Right? So when we try this log base 17 of 139, right? Calculators, our calculators specifically cannot do that. But what they can do is they can do the log base 10 of 139 and the log base 10 of 17, which is 2.143 divided by 1.23, okay, which gives us 2.143 divided by 1.23. 1.742. Okay. Now, some of you who have used graphing calculators before may know that your graphing calculator will do these, but as of now, UMKC doesn't want that, and so what they want us to do is use this change of base formula. Right? Just as a quick comparison, I know that I'm not going to do all these, but I will do this next one. Right? Log base 4 of 23. I'm actually going to do this one by switching it to the natural log of 23 divided by the natural log of 4. All right, and one thing to kind of keep in mind while I'm doing this calculation is that the biggest mistake I see with these is just switching which order we do it, kind of switching the numerator and denominator. And my suggestion with remembering the correct order is the top is always the same input, right? It's 23, 23, 139, 139. That won't change. All right, the bottom is just that counteracting or taking into consideration the original base that we're changing from. You know, it's not the best solution, but that's what I got to kind of help you with this. All right, so as you can see, as I'm doing this all, we get an answer of 2.262. Okay. With rounding, I don't know if you guys have noticed, I traditionally say round to 3 decimal places. I don't care, but 3 kind of keeps you safe in most cases.